Right, so the last time we were discussing, we were basically looking at physical properties of fatty acids. Okay, we were looking at the melting points, how the melting points were increasing as you increase the number of carbons. Then we also looked at how the melting points were reducing as you increase the number of double bonds. Okay, so I labored to explain that when you increase the number of double bonds, the melting point reduces. Okay, right. So here I've basically written the same structures that I gave you, the polyunsaturated fatty acids. Okay, if you remember, this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. Okay, sorry, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, so the double bond must be here, 12, 13, 12, 13, 14, 15, 16, 17, 18. Okay, here there are how many double bonds? There are 3, so we can as well do it this way. Okay, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. So one must go out. Okay, so we said that this, we called it as, if it is 18, we said it is octane. I'll go through again what I was going through. So we said this is octadecanoic acid, that's where it's coming from. So since it has a double bond, the double bond is at position number 9 and position number 12. We said that we need to insert between A and N, we need to insert the di for 2 and the E for an alkane, then acid. Okay, 9, 12 octadinoic acid. Okay, of course we said this is a cis. Right. We said that this is called the linoleic acid. Linoleic acid. This one we said also is a cis. Okay, the double bond is at position number 9 and position number 12 and position number 15. So we call this as an octa from octadecanoic acid. Okay, so we'll put the prefix tri for 3 and the E for an alkane, so ethanoic acid. Okay, cis 9, 12, 15 octadecatrionic acid. Okay, we said this is called the linolenic acid. Linolenic acid. Of course, this one we said it has one at position number 5, another one at position number 8, another one at position number 11, another one at position number 14, and they are in the cis position. So and this 20, so it's coming from icosanoic acid. Remember, it's coming from icosanoic acid. So between A and N we put tentra, then the E followed by noic. Okay, so cis 5, 8, 11, 14 equals tetranoic acid. We call this as arachidonic acid. Arachidonic acid. Okay, right, so we said that these are proof. If you remember, I said these are PUFA if you want. Okay, that's a short for polyunsaturated fatty acids. Polyunsaturated fatty acids. Okay, right. So sometimes there is a way of naming these fatty acids. Okay, this fatty acid can be named in a number of ways. One of the ways we can name these is by what is known as the omega notation, okay, or the Greek alphabet notation. Okay, the Greek alphabet notation. Okay, or we can use the IUPAC notation. The one we are using is the IUPAC notation. Okay, right. So let's look at the Greek letter notation. Okay, the Greek letter notation, we look at the position of the last double bond from the terminal end. Remember, we start from there. This is carbon number 1. This is carbon number 18. So counting from the last carbon, okay, how many carbons are there before you reach the double bond? So if we count, there's 1 here, 2, 3, 4, 5, 6 carbons. Okay, so you notice that there are 6 carbons. Okay, here, how many carbons are there before you reach the last double bond? 1, 2, 3 carbons. So you see that there are 3 carbons. Here, how many carbons do you see? 1, 2, 3, 4, 5, 6 carbons. Okay. So, remember, when you are using the Greek letter in naming acids, we say that this is an alpha carbon. This is a beta carbon. This is a gamma carbon. This is a delta carbon. This is a epsilon carbon, and so on and so forth. The last carbon is said to be the omega carbon. Omega. Remember, for those who are Christians, we say that God is our Alpha and the Omega. He's the beginning and the end. So, using that Omega word, end, this is the end. Okay, so W is Omega. So this is the Omega, this is the Omega, this is the Omega. Okay, so using the Greek letter notation, we can classify particularly polyunsaturated fatty acids as the omega fatty acids. Okay, omega fatty acids. Okay, so we can say that, for instance, linoleic acid, okay, has 6 carbon before the double bond, so we say it is a 6 omega fatty acid. Okay, if you look at linolenic acid, it has 1, 2, 3 carbons, so it's a 3 omega fatty acid. Okay, then you also have this one, 6 carbons, it's also a 6 omega fatty acid. Okay, so you can have 3 omega, you can have 6, sometimes you can even have the 9 omega, but the common ones are the 6 and 3 omega. So fatty acids can be said to be the omega fatty acids, and we are referring to those that have a double bond. Okay, and look at the last double bond, how many carbons are there up to the end from the terminal of the double bond? How many carbons are there to the last carbon? 1, 2, 3, 4, 5, 6 carbons. So it's an omega fatty acid. Okay, now omega fatty acids are very essential in our diet because they tend to prevent diseases such as hypertension. Okay, they are very good in prevention of hypertension. Okay, they are very good in preventing heart diseases. Okay, they are very good also in prevention of diabetes. Okay, diabetes. Okay, just to mention a few. They're very good for the skin also. Very good for the skin as skin toners. Okay, of course I can't forget to mention that they help in prevention of cancers. Okay, they help in the prevention of cancers. So omega fatty acids are very good in the prevention of hypertension, which is high BP, raised BP, okay, raised BP above normal, heart diseases, diabetes, that is raised sugar above normal, okay. Okay, it's good for the skin, and then it's good for prevention of cancers, as it were. So we need these omega in our diet. Okay. The other nomenclature that we use for naming fatty acids, we can use what is where we just look at the number of carbons. Okay. For instance, we can say this is 18 carbon compound. Okay, 18 carbon compound. Then you have a full colon there. Full colon, then you say how many double bonds do you see? 1, 2. So I have 2 double bonds. Okay. Then you say, okay, what configuration are the double bonds? You say they are cis. Okay. Then you say which position is a double bond? So you say delta 9 and delta 12. Okay. So that is the abbreviation. Okay, that is the abbreviation that we can use, okay, for linoleic acid. For this one, we can say, okay, still it has 18 full colon, but it has 3 carbons. Okay, then the double bonds are in the cis position. In delta, the double bond is at position number 9, position number 12, position number 15. Okay, when I write like this, then you know that I'm talking about linoleic acid. Okay, the other one, arachidonic acid, I can say there are 20. They are 4 double bonds. Okay, they are all in the cis position, and they are found at position number 5, position number 8, position number 11, and position number 14. Okay. If it is oleic acid, for instance, oleic acid, we can say oleic acid has 18 carbons. Okay, it has 1 double bond. The double bond is in the cis position at position number 12. Okay. If you are talking about stearic acid, for instance, stearic acid has 18 carbons. How many double bonds? It has no double bond. Okay, that would be stearic acid. Okay, no need to show the position of a double bond because there is no double bond, as it were. Okay, so that's how you can abbreviate fatty acids, or that's how you can name fatty acids. Okay. Now we proceed on and look at other aspects. So we were looking at fatty acids. Okay, we were looking at fatty acids, but remember where we've come from. Where are we coming from? We're coming from classification of lipids. Okay, what brought us here is that we started defining what simple lipids are. Okay, we started defining what simple lipids are. What did we say simple lipids are? We said that simple lipids are esters of alcohol and fatty acids. Okay, the fatty acids, of course, are high molecular fatty acids. A higher molecular fatty acids. Okay. We also said that a simple lipid is a lipid that, when hydrolyzed, will produce an alcohol and a fatty acid. Right. But to be very detailed, we would say that simple lipids are triesters. Are triesters of an alcohol and fatty acids. And fatty acids. Okay, so they are triesters. Okay, remember we said we looked at the alcohol. The alcohol that we looked at was this alcohol, glycerol. Okay, this is glycerol. Okay, that's our glycerol. That's our glycerol. That's our glycerol. Okay, that's it, glycerol. Okay, so we said that glycerol can react with fatty acids. Glycerol can react with fatty acids. Let me represent fatty acids this way. I'll put 3 molecules. Why 3 moles? Because there are 3 hydroxides here. Okay, so once you react these, okay, of course you know that if it's in the lab, we would put amino acid there, such as hydrochloric acid, conc-hydrochloric acid. Okay, so what will be formed is that an ester will be formed here. So an ester is formed here. Okay, then here we also form. Okay, it's better to write it in this direction. We have another ester here. Okay, of course there will be hydrogen, then there will be this hydroxide will react with another fatty acid to form that kind of a compound. So what you see is that there is an ester here. This is an ester bond. This is an ester bond. Let me put it in brackets. Okay, that's an ester bond. That is also an ester bond. Okay, that is an ester bond. That is also an ester bond. Carbon ester. Okay, so that's why you are saying it is a triester. This which we have formed is a lipid. It is a triester. Okay, one glycerol reacts with 3 molecules of an organic acid, and in the process you form a triester. This is a triester that we have formed. Okay, of course the whole process we know it as esterification. You looked at this in O-level chemistry, even at A-level chemistry, you were looking at this. Okay, hydrochloric acid is acting as a catalyst, enhancing the reaction, okay, speeding up the chemical reaction. But all that we are interested in is this simple lipid. When you hydrolyze this is a reversible reaction actually. This is a reversible reaction. When you hydrolyze, it will go in this direction, producing your glycerol and your fatty acid, as it were. Okay. In organic chemistry, of course, you looked at this structure. This structure, okay, which is bonded somewhere. What do you call this? I know you can't answer because you're not here. Ideally, we call this as an acyl group. Okay, an acyl group. We find an acyl group in esters, you find an acyl group in acids, you find an acyl group in amides. So that is called an acyl. Even in ketone, you find this acyl. If you remove the other group, we can call this as an acyl. Okay, where you have a carbonyl group attached to a radical, or a carbonyl carbon attached to a radical. That is an acyl group. Okay, so we can say that the product that has been formed is a triacyl. Okay, 3 acyl groups, 1, 2, 3 are connected to glycerol. So we can say triacyl glycerol. Triacyl glycerol. Okay? So simple lipids are triacyl glycerols. Okay? Simple lipids are triacyl glycerols. Okay? Others actually call it triglycerides. Triglycerides. Acylglycerol. TAG. Okay? Triacylglycerol. So what I'm trying to establish is that simple lipids are triacylglycerols. Or simple lipids are triesters of alcohol and fatty acids. Okay? Ideally, what you see is that this compound must be neutral. There is no polarity that you can see here. These compounds are basically neutral compounds. The features of simple lipids, okay, the features of simple lipids is that they are non-polar, or put differently, they are neutral compounds. Okay, right. So how do we name these simple lipids? Okay, how do we name these simple lipids? But before we go to the nomenclature, I must say that these lipids can be classified into two main groups. Okay, these lipids can be classified into two main groups. Okay, we have what are called the simple triglycerides, simple triacyl glycerols, and the mixed triacyl glycerols. Okay, so we can divide simple lipids into two main groups: simple triacyl glycerol and mixed triacyl glycerols. Okay, simple triacyl glycerol are simple lipids that contain the same type of acyl group. The same type of a fatty acid is the one that is joined to the 3 hydroxide groups. That is a simple lipid. If you have a different R at 1 and a different R at 2 and a different R at 3, then it is referred to as a mixed triacyl glycerol. Mixed triacyl glycerol. So that's the definition. Simple triacyl glycerol are simple lipids that contain the same type of fatty acids joined to glycerol. Mixed triacyl glycerol are lipids that have different fatty acids. Different fatty acids, as it were. Okay, I hope we are together. I hope we are together. Right. Okay. So maybe let me give examples of what I mean before someone gets lost. Okay. Okay. So instead of putting R here, I'll say palmitic acid. It's not even right, but I'm just trying to demonstrate it. Okay, and here I also have palmitic acid attached. Okay. Okay, let me say palmitoyl group, not palmitic acid, may not be right. Palmitoyl group, and I also have palmitoyl group here. is part of permitting group. Okay, so what you see is that this triacyl glycerol is made up of glycerol, yes, and the same type of acyl group. Okay, same type of acyl group. Okay, such is called a simple lipid. Okay, a simple lipid. But if here you have stearic acid and here you have oleic acid, then that becomes a mixed fatty acid. Okay, a mixed fatty acid. Now I must state that these simple lipids are used for storage of energy in our bodies. Like we use carbohydrates, we learned in O level that carbohydrates are used for storage of energy in our bodies. Similarly, simple lipids can be used to store energy in our body. When we've run out of food, we are starving for whatever reason, we can fall back on simple lipids, carry out hydrolysis and use the products to produce energy. Okay, so we can use simple lipids for storage of energy in our bodies. That's one of the main functions. There are other functions that we will talk about as we proceed. Okay, so if a fatty acid was like this, if the lipid was like this, how do we name it? Okay, so we would say that this is tri. Okay, remember this is coming from palmitic acid. Okay, so we would say this is tripalmitine. Okay, so we replace the C with the N, tripalmitine. Okay, tripalmitine. If it was stearic acid, for instance, it would be I'll first write stearic acid. So you replace the C with I. So you have tristerine. If it was oleic acid, it would be I'll write oleic acid. Okay, then we remove, of course, the oleic acid and remove the C with the I, trioleine. So that's how you do name the simple lipids. Okay, but let's have an example where we have oleic acid here. Okay, maybe here we have stearic acid group here. Okay, so how would you name? Okay, so we would say that at position number 1, okay, at position number 1 we have there is palmitic acid